everyone, this is the third chapter of mechanization of estate operation, and this is regarding engine construction and components. In this chapter, you will learn about internal combustion engines, 4-stroke and 2-stroke cycle engine, diesel engine, petrol engine, engine cylinder, engine valve, piston assembles, crankshaft, and also the flywheels. As an introduction in thermodynamics and engineering, a heat engine is a system that converts heat or thermal energy to mechanical energy, which can then be used to do mechanical work. It does this by bringing a working substance from a higher state temperature to a lower state temperature. We have an engine that can be put into category according to the two criteria. The first one is the form of energy it accepts in order to create the motion. The second one is the type of motion it outputs. And the two general categories for engines are internal combustion engine and external combustion engine. An external combustion engine, or we call it as EC engine, is a heat engine where an internal working fluid is heated by combustion of an external sources through the engine wall or heat exchanger. The fluid then, by expanding and acting on the mechanism of the engine, produce motion and usable work. And the fluid is then cooled, compressed, and reused in a closed cycle, or less commonly dumped and cooled in an open air engine. A simple steam engine is an example of external combustion engine. A steam engine is a heat engine that performs mechanical work using steam as its working fluid. The steam engine uses the force produced by steam pressure to push a piston back and forth inside a cylinder, and this pushing force is transformed by a connecting rod and a flywheel into rotational force for work. A typical steam engine is the steam locomotive engine. A steam locomotive is a type of railway locomotive that produces its pulling power through a steam engine. These locomotives are fueled by burning combustible material, usually coal, wood, or oil, to produce steam in a boiler. And the steam moves reciprocating pistons, which are mechanically connected to the locomotive's main wheels, which is the drivers. And both fuel and water supplies are carried with the locomotive, either on the locomotive itself or in a wagon that pull behind the locomotive. And now we go to the internal combustion engine. An internal combustion engine is a heat engine in which the combustion of a fuel occurs with an oxidizer, usually air, in a combustion chamber that is an integral part of the working fluid flow circuit. In an internal combustion engine, the expansion of the high temperature and high pressure gases produced by combustion that applies direct force to some component of the engine. The force is applied typically to pistons, turbine blades, rotor, or a nozzle, and this force moves the component over a distance, transforming chemical energy into useful work. The diagram shows a cylinder as found in 4-stroke gasoline engine. As you can see, the C is the crankshaft, DE is the exhaust camshaft, I is the inlet camshaft, P is the piston, R is the connecting rod, S is the spark plug, V is the valve, red valve is the exhaust valve, blue valve is the intake valve, and W is the cooling water jacket, and the gray structure is the engine block. The figure shows the essential components of an engine, and it consists of a cylinder. Okay, this is the cylinder block into which the fuel is introduced for burning, and then we have a piston which moves up and down within the cylinder, and we have the cylinder block where it seals off the top of the cylinder, a crankshaft which rotates by the piston on power stroke, and a connecting rod, and which connects the piston to the crankshaft, and these two components convert reciprocating motion of the piston into rotary motion of the crankshaft to form a usable means of power. And then we have a gudgeon pin which connect the connecting rod to the piston, and also an inlet valve which allows the fresh charge of fuel and air into the combustion chamber, an exhaust valve which allows the spent gases to escape to the atmosphere via the exhaust system, a camshaft which opens the valve spring which closes the valves, and a flywheel that feeds to the crankshaft which absorbs power on the power stroke and gives energy. And this is a typical arrangement of essential parts within one cylinder. As you can see here, you can see the spark plug at above, and then the piston that connect to the connecting rod and is connected to the flywheels. And then we have a timing gears, the camshaft, the tappet, the valve spring, the gudgeon pin, and also the valve. And tractors engines are usually 4-cylinder engines, but it is uncommon for them to have 6 cylinders. 1 to 3 cylinders also has been used. And whether an engine is vertical, horizontal, or in a single or multi-cylinder, it does not alter the method in which it operates. And there are 3 arrangements which may be used for an engine. The first one is inline engine. This is the cylinder that are arranged in a single row on which one behind the other, and they may be in vertical as in most modern light vehicles, horizontal as used in a coaches where the engine is positioned under the floor, or inclined at an angle to allow for a lower bonnet line. And the second one is the V engine. This is the cylinder that arranged in 2 rows at an angle to one another. And the angle for 2, 4 and 8 cylinder engines are usually at 90 degrees. And for 6 and 12 cylinder engines, the angle is usually 60 degrees. And the third one is opus piston or cylinder engine, or we call it as a flat arrangement. This is where the cylinders are at an angle of 180 degrees apart and usually positioned horizontally. And this is how the engine works. The first one, we have to know that the engine works by the combustion, which also known as a burning. This is the basic chemical process of releasing energy from a fuel and air mixture. In an internal combustion engine, the ignition and combustion of the fuel occur within the engine itself, and the engine then partially converts the energy from the combustion to work. And the engine consists of a fixed cylinder and a moving piston, and the expanding combustion gases push the piston, which in turn rotate the crankshaft. This ultimately through a system of gears in a powertrain, and this motion drives the vehicle wheels. And there are 2 kinds of internal combustion engines currently in production, which is the spark ignition gasoline engine and the compression ignition diesel engine. And most of these are 4-stroke cycle engines, that meaning 4 strokes are needed to complete a cycle. And the cycle includes 4 distinct processes, which is intake, compression, combustion, and power stroke, and also exhaust. We have a 4-stroke engine, and in this 4-stroke engine we have the induction stroke, the compression stroke, the power stroke, and the exhaust stroke, while in the 2-stroke engine we have the stroke 1 and also stroke 2. Practically, the diesel engines and the petrol engines are quite similar. They are both internal combustion engines that designed to convert the chemical energy which available in the fuel into the mechanical energy. And both diesel engines and the gasoline engines convert fuel into energy through a series of small explosions or combustions. And the major difference between diesel and gasoline is the way these explosions happen. The spark ignition petrol and the compression ignition diesel engines differ in how they supply and ignite the fuel. In spark ignition engine, the fuel is mixed with the air and then inducted into the cylinder during the intake process. And after the piston compresses the fuel air mixture, the spark ignites it and causing combustion to happen. The expansion of the combustion gases pushes the piston during the power stroke, and in a diesel engine, only air is inducted into the engine and then it compressed. Diesel engines then spray the fuel into the hot compressed air at a suitable measured rate and causing it to ignite. And this is the example of four-stroke cycle in spark ignition engine. The engines that are designed to run on petrol engine require an electric spark to ignite the fuel and air mixture, and these are known as spark ignition engine. As you can see in the picture, you can see the spark plug situated above the piston. And this is the four-stroke petrol engine that use the spark ignition. In this four-stroke petrol engine, we have four cycle, which is the intake stroke, compression stroke, power stroke, and exhaust stroke. In suction or intake stroke, the piston moves from the top dead center, which is the farthest position of piston, to the crankshaft to the bottom dead center, which is the nearest position of piston to the crankshaft. The piston moves downward, sucking the air-fuel mixture from the intake valve. During this cycle, the intake valve is open, the exhaust valve is closed, and the crankshaft rotation is about 180 degrees. And the second is the compression stroke. Here, the piston moves from the BDC to the TDC and compressing the air-fuel mixture, and the momentum of the flywheel helps the piston to move upwards. And during this cycle, the intake valve is closed, the exhaust valve is also closed, and during the power stroke, which is the third cycle, the second rotation of crankshaft has begun as it completes one full rotation during compression stroke. Power stroke begins with the expansion of air-fuel mixture, which ignites with the help of the spark plug. Here, the piston moves from the TDC to the BDC, and this stroke produces mechanical work to rotate the crankshaft. During this cycle, the intake valve is closed, the exhaust valve is closed, and the crankshaft rotation is about 540 degrees. And the last one is the exhaust stroke. Again, the momentum of the flywheel moves the piston up from the BDC to the TDC and thereby driving the exhaust gases outside through the exhaust valve. And during this cycle, the intake valve is closed, the exhaust valve is open, and the crankshaft rotation is about 720 degrees. This figure shows the components available in a single cylinder of four-stroke engine, from the intake valve to the crankshaft. And now we go to the two-stroke engine using the spark ignition. The two-stroke engine is a type of internal combustion engine where one power cycle is completed with two strokes of the piston during only one rotation of the crankshaft. And this engine designed to provide power for small machines that use on farms or in horticultural work. For example, in hand-operated hedge trimmers, hand-operated chainsaws, small rotary cultivators, rotary grass cutters, and horticultural sprayers. The two-stroke engine performs all the same steps which are performed by four-stroke engine. The two-stroke engine perform all the same steps which are performed by four-stroke engines like suction, compression, expansion, and exhaust. But the two-stroke engines perform these all steps in only two-stroke, unlike the four-stroke engine which completes one power cycle in four-stroke. But in two-stroke engines, it has a slightly different from four-stroke engines because no valve is existing instead of opening known as part. And this opening or part known as inlet part, where the carburetor is attached and the fuel and air enters into the crankcase, and the transfer part, which is number 2, where the compressed fuel and air is transferred from the crankcase to the combustion chamber, which are ready for the compression stroke. And the third is the exhaust port, where at the end of the power stroke, the piston uncovers the exhaust port and spent gas escape. And the crankcase is sealed compartment and acts as fuel or air pump for the engine. Unlike for the four-stroke cycle, the two-stroke engines send the piston down on every downward stroke. The two-stroke engine performs all the same steps which are performed by all the four-stroke engine, where the two-stroke engines fire once every revolution while four-stroke engines fire once every other revolution, and this gives two-stroke engines a significant power boost. The two-stroke engines can work in any orientation, which can be important in something like a chainsaw, and a standard four-stroke engine may have problems with oil flow unless it is upright, and solving this problem can add complexity to the engine. And these are advantages that make two-stroke engines lighter, simpler, and less expensive to manufacture. In the two-stroke cycle during the stroke 1, as the piston moves up on the compression of a previous charge, a partial vacuum is created in the sealed crankcase, and then the piston uncovers the inlet part and air rushes through the carburetor, taking fuel and oil mixture with it into the crankcase. During the stroke 2, the previous charge now ignites, pushing the piston down on power stroke, and this seals the fuel air in the crankcase and compresses it. When the piston reaches the bottom dead center, the exhaust ports are open and the spent gases escape. The biggest difference to notice when comparing figures is that the spark plug fires once every revolution in the two-stroke engines. And now look at the picture. This picture shows another variant of the two-stroke engine in which the inlet and outlet ports on the same side, and here there is no need to open inlet ports intermediately, and the cylinder head is designed such that the exhaust port is closed during combustion and opens after the combustion. The piston itself closes and opens the port accordingly, and the process remains the same, but difference here is just the design. And now we go to the diesel engine. The diesel engine uses a four-stroke combustion cycle just like a petrol engine, but because higher pressure and thrust take place within the engine itself, it is made stronger. The four strokes are the intake stroke, compression stroke, combustion stroke, and the exhaust stroke. Now you can see the moving picture on how the four-stroke cycle diesel engine works. A four-stroke diesel engine resembles a gasoline engine as it works on the four-stroke cycle, that is admission, which is the intake stroke, compression stroke, power stroke, and also exhaust stroke. And when the piston gets down on the air admission stroke, the lower pressure in the cylinder allows a charge of air into the cylinder through the inlet valve, which opens just before that center. Once the piston has passed the bottom dead center and is beginning to ascend, the inlet valve closes and the upward movement of the piston compresses the air charge in the cylinder, causing a quick rise of temperature. Before the second stroke is over, the charge of fuel is gradually injected into the cylinder by an injector, and the burning of the air-fuel charge makes the gases expand. They push the piston downwards and create the power stroke. Before the piston reaches the bottom dead center, the exhaust valve opens and the piston goes up again, and the burnt gases are forced out through the exhaust valve. Just before the top dead center, the inlet valve opens. The cycle begins again. Now you can see the position of piston during each cycle. You can notice the differences of the position of piston during 4 cycles. Please remember that the diesel engine has no spark plug, that it intake and compress it, and then it inject the fuel directly into the combustion chamber, and we call it as a direct injection. And this is a heat compressed air that lights the fuel in a diesel engine. Starting a diesel engine is a lot different than starting a gas-powered engine. Whereas a gas engine starts when the fuel is ignited by the spark plug, the diesel engines relies on the heat created by compression in the chamber. The most common method for starting a diesel engine is through the use of glow plugs. Like an air intake heater, the glow plugs operate off of the power of the vehicle's battery, and this pre-warming process brings the air in the combustion chamber up to a temperature conducive enough to cold starting. Sometimes, such as during cold weather, the diesel fuel needs the aid of an outside source of heat to reach the appropriate temperature to start. Now we look at this table. This table shows the differences and advantages of diesel engine and petrol engine. The differences of both engines can be seen at the intake stroke, compression ratio, ignition system, fuel type and its consumption, and also its thermal efficiency. and the differences of 4-stroke engine and 2-stroke engine are shown in the table.